Greetings, we are back to the complex numbers. We are going to calculate this power. We have to find z. If we say z is equal to the quantity 1 plus I to the power 4. We are going to use two ways to solve this one. The first way is to use the Pascal triangle to find the coefficients and then find the expansion and then calculate. That is manual. So we have 1 for 1, we have 1 1, and for 2 we have 1 plus 1 is 2 in the middle here, then 1 2 and 1, and here 1 1 plus 2 3, 2 plus 1 3, and then 1, and then 1 here, 1 plus 3 4, 3 plus 3 6, 3 plus 1 4, and then 1. So for the coefficient for the power of 4, we have these coefficients 1 4 6 4 1. We are going to use those coefficients to calculate our expansion here, and we go back to our z. We can say z is equal to 1 plus I to the power 4. So we say it is equal 1 to the power 4 is 1, okay, plus 1 cubed times I, this is I, 2 times 4, of course, the coefficient, plus 6 times I squared here, okay, plus 4 I cubed, okay, and then plus I to the power 4. And we are going to calculate this. We know that I squared is equal to negative 1. 1 to the power 4 is 1, plus 4i minus 6, plus 4 times I squared is minus 4 times I, and then plus r squared I squared is 1. So if we do the calculation here, we group similar terms. We have 1 minus 6, and the plus 1 is minus 4. This is the real part of the resulting complex number. And for the imaginary part, we have 4i minus 4i, that makes it 0i. So actually we get just a real number at the end. So z is equal to negative 4. That's the solution here. We are going to use another method to solve this one. We are going to use the exponential powers, and if we this time say z is equal to 1 plus I, and then we want to find z to the power 4, and we are going to find the modulus of z is equal 1 plus 1 squared is equal to square root of 2, and we just express z in terms of theta. So we know that it is a modulus times cosine theta plus I sine theta, and we are going to replace these terms by the values. We have the modulus and we have the values also. So we have square root of 2 times 1 over square root of 2 to make the real part 1, and then plus I square root times 1 over square root of 2 to make it I in the second verse. So this is still the same 1 plus I, and the angle, base angle corresponding to this is equal to pi over 4. This is the base angle, or we can call this argument of this complex number. So z argument z is equal to pi over 4. And we are going to use this interesting result to express a z in an exponential manner. So we can say z is equal to the modulus, which is equal to square root of 2 times e to the power of I pi over 4. That is the value of this complex number. So now if we take the power of 4 of that, we have to take the power of 4 of the modulus and then times e to the power of I pi over 4, now times 4, and we do some simplifications here, and we get e to the power of I pi, and you know that square root of 2 to the power of 4 is 2 squared, of course, okay. Order minus 6 is 4, and then times e to the power of I pi. So if we have that, we are going to get back to our regular format now, and we know that pi, we get 4 times cosine pi plus I sine pi, and as you know, sine pi is equal to 0 and cosine pi is equal to -1, so we get z to the power of 4 is equal to 4 times -1 plus 0i is equal to -4. So in this situation, again, we found that 1 plus I to the power of 4 is equal to -4. Thank you for watching, and see you in videos for other topics. Bye bye.